industry-assisted lecture series on hands-on session using data prep kit for fine-tuning LLMs. This is the session 2. I am Robin from PAL's Program Management Office. I will be moderating this session today. I would like to reiterate the basic instructions once again. For easier identification, please rename your Zoom display name as college short name hyphen your name. Participants will stay muted and allowed to unmute only during the Q&A. Chat box usage will be restricted. You can message the host or the co-host. We will enable it only on need basis. During the session, if you have any questions to be asked to the speaker, please write it to askpalspmo@gmail.com. This mail will be monitored throughout the session. Ensure to write your name and college short name as well along with the question. The other way to ask your question is to use the raise hand option to interact with the speaker. Attendance link will be posted soon. Make sure to mark your attendance. Please close the browser right immediately after you mark your attendance. Participants are requested to register in Slido at the beginning of the session. Feedback link, recording, and presentation material will be shared by mail post the session. Now, I request Mr. PVM to give the opening remarks and followed by CNC introduce the speakers. PVM.
Thank you, Robin. It's my privilege today to give a small welcome talk before the actual session starts. Thank you very much, CMC, for giving me this opportunity. A very warm welcome to Kamal Das, sir, as well as the faculty from IBM today, that is Shivdeep Singh and Achal Goyal. Very warm welcome to you. Warm welcome to all the faculty and students who are present in large numbers. It was great to see more than 1,800 registrations for this program. I think it's almost like a record. And great to see that yesterday also there were more than 1,000 who actually participated in the session. I'm hopeful that today, as well as in the coming days of the session, the participation will continue to be exceeding all expectation. Now, maybe it was already told to you yesterday, but I think it's important to dwell that PALS is trying to do these lectures in a different way since the last year. Instead of just looking at it like a ad hoc one lecture session, which is neither here nor there, and the students and faculty do not get much out of it. Based on the feedback we received from the colleges, we have tried to make these lecture series into a more deeply involved sessions. Each lecture series on a particular topic actually encompassing 3 to 4 to 5 sessions. And not only are these lecture sessions also including a lot of interactive element and hands-on exercises, which combine along with these lectures to really give a wonderful value add to the students, and they get a very intimate and a deep knowledge of the subject. And IBM have really partnered with us and helped us to propagate this format and fine-tune it to make it into something really excellent. Like, for example, the IBM research volunteers last year, they engaged in a series of initiatives for them to give back to society and through PALS too. Collaborating with PALS, they conducted talks, demos, and hands-on sessions on technologies like AI, quantum, hybrid cloud, and blockchain across our 40-odd colleges, reaching 4,000 students and faculty. And in the process, the research faculty at IBM also won a Global Volunteer Award from the IBM headquarters in USA. I think that is a fantastic achievement. And this year, our involvement with IBM is going to be more intimate. More number of events is what we are looking at in collaboration with them. And what a wonderful start it is. I think LLM being the subject of the day, of great interest to all students and faculty, I think we are starting with a bang with this session. I'm sure you must have had a wonderful session yesterday, and it will be carrying on today and for the next few sessions. What, of course, I would like to tell the students is, please attend all the sessions, because no one session is complete by itself. We would like you to attend all the 4 or 5 sessions which are involved in this series, so that you get a total idea and you get different aspects of the subject, which is large language models. And attending all the sessions will actually entitle you to get a certificate. If you just attend 1 or 2 sessions, it doesn't entitle you to a certificate. So we are looking at committed students who would attend all the lectures, so that not only do they get the knowledge, you'll also have a certificate backing to go with it. So having said this, I don't want to take much more of your time from the actual session. I hand you over to CNC to introduce the faculty who are going to talk in today's program. Thank you very much and all the best.
Thank you, PVM. It's my honor to introduce the scientist from IBM India Research Lab. So today we have Dr. Shivdeep Singh and Dr. Anshul Goyal. Dr. Shivdeep Singh is a research engineer at IBM Research in Bangalore, India. He is currently working to build data engineering pre-processing components and pipelines for data preparation for LLMs. He was involved in processing data at scale for IBM Granite models, which are now open source. His research is focused on data processing and data preparation techniques, and is also involved in the development of data prep toolkit, an open source toolkit for processing data at scale for LLMs by IBM. Thank you, Dr. Shivdeep, for taking your time out for reaching out to students. Would Dr. Anshul also will be joining you, or she will be doing a separate session? Dr. Shivdeep?
She is with me. She has joined the same session, but like she may help in the Q&A.
Okay.
I would take the hands-on session.
Okay, let me take a few minutes to introduce her too. Okay, Dr. Anshul Goyal is a senior research scientist at the IBM Research Lab in Delhi, India. With over 10 years of experience at IBM, her expertise lies in applied mathematics, data analytics, and artificial intelligence. Wow. Dr. Goyal is currently focused on exploring methods for data curation, filtering, and feeding data to existing AI models. This research aims to improve the overall performance and effectiveness of AI systems. Before this, Dr. Goyal was involved in research on compute sustainability. This included quantifying the carbon footprint of on-premise hardware and cloud infrastructure, promoting more environmentally friendly computing practices. So this is amazing, the kind of people that we have today for interacting with students to show the data preparation toolkit. Post the session day before yesterday, when you heard from Hema Patel and Shailija Thakur, how important is data in LLM context. And they also mentioned about the data preparation challenges. They gave a small introduction to data preparation kit and talked about a little bit of algorithms. You all heard, you become expert. Now over to Dr. Shivdeep and Dr. Anshul for hands-on session using this toolkit. Over to you, Dr. Shivdeep and Dr. Anshul.
Yeah. Hello. Good afternoon, everyone. So I'm honored to present this data prep toolkit to this audience. So I'll try to keep it very simple so that anyone is able to grasp things. So we'll progress slowly and learn about various concepts in this hands-on session. So I would share my screen and I'll take you through some magic. I think, do I have the permission to share the screen?
Yes, you do.
You can share your screen.
Yeah.
This Zoom is actually giving some problem. Okay. Let me
There's a
try.
share screen at the in the ribbon at the bottom.
Yeah. I was trying
Click
that
on that.
too, but that share button click was not
Ah.
working. So, are you able to see my screen?
Yeah, we can able to see your screen.
Yeah.
PPT
Yes.
hands-on with data prep.
Yeah. Sure. So
Okay, you have to
now,
go to the slideshow mode.
yeah. Actually, I will go this way. I have to. I iterate between multiple tabs. So this is hands-on with data prep toolkit. So just last time we had one session where we talked somewhat about Hima and Shalja talked about data prep and data prep toolkit. I'll just try to come back to that. Let's think of data. What is data? And since we are trying to uh, do data preparation of data which would be used in LLMs, we might have known, like we know there is something on LLMs now. Large language models are popular, and people are actually amazed to see what they can do. I'll just show you something here. So we have one IBM's large language model which can do coding. So suppose I ask it like write a program in Python to sort a not I will keep it difficult to generate pi using Monte Carlo simulation. So we see that it has generated some code in Python. This is a model which is capable of generating a code in Python. I can change the language. I change it to C++. Now it's coding in C++. So if I don't want to code, I want to ask it to generate diagrams. This will generate diagrams for me. Now the thing is, these things look magical to us. Like you just gave it some problem and it is trying to give us some output, which is like it can give us code, it can give us answers. So these large language models are catching everyone's eye these days. But how do they know these things? How do these large language models can do these things? So the answer lies in data. Data means we actually train these models on very large number of programs, very large number of text, and we it's very large volume of data which was used to train these models. So these models are able to perform something. Now there is a catch in the data. If you give good data, model would be performing better. If your data quality is not good, the model, it may impact model's performance. So data is the food for the model. Data is something which controls the health of the model. It's just like we take food. If the food has some problem, then we are getting the problem. So in case of models, if we actually train it with good quality data, the model would have good quality answers. So, and before training model and before fine tuning model, so in models we have fine tuning and training. There are two steps. Like first we train the model, then we can train it again as a second step with some small data. So it's called fine tuning. So in both of those steps, we use data, and we are called saying data, this data, that data. But as students would be there, and faculty, many people. So I would like uh, to let you have a glance at what data is in this case. And then we'll also follow how these things are. So data is represented, data is actually, to represent data, we use something called dataset. Dataset will have multiple data samples. So there would be multiple ways to represent data. There would be some places where we can keep data. So I'll just show you some data. There is some popular repository called Huggingface. So on Huggingface, we can host data. So we are going to take a look at this code parrot data on Huggingface to see how it looks like. So if we see, I already have a small sample of this. So this data in code parrot, it looks like a key value pair. There is something called code, then there is some code, then repo name. So it looks like a dictionary which has a key and a value pair. So this is one sample. Imagine millions of such samples. So, and each sample is called data sample. When millions are there, or uh, some finite number of them are there, we call it a data set. So data set can be stored in multiple formats, like this format which is shown here. It's called JSON, and this is text based. It is written in text. So this is not very efficient. You might have seen Excel files or CSV files where we can keep data in the form of rows and columns. So though that is basic representation of data. So data has to be represented in some format, and this format which we will go through is kind of a table. Table means it will have rows and columns. Here the column names have some meaning. Like this is a code column. This would be a repository name column. This would be path column, language column. So these columns have meanings and the rows have content. Let's see if Hugging Face, wait, this will go to the Hugging Face link, code parrot link, to see the data card there. So usually when big companies host data, they will also give something uh, which has information about the data. It is called data card. Data card will have some representation that this code field is of which type. So not only these columns have names, they also have data types. So representing data sets, like I just gave you one example for JSON. Very small data can be in this format, but when we process data for LLMs, when we process data for bigger models, when we want to do analytics on them, when those things are done, data is usually in binary format. So there is a popular in-memory representation format for data called Apache Arrow. So it will represent tables which will have rows and columns. And in memory, when we represent, it would be in the form of table. And when we want to store it for persistence, we want to save it on our computer, or we want to save it on cloud, it is usually stored in a format called parquet. So this is a popular format, and we will be processing the data in form of this parquet format. So up to now, we have just seen one data sample, and we know that this can be represented in tables, and we have something called parquet files where we can actually keep, I think code parrot is server is not working today. Like this is hosted by Hugging Face. So we will go to our next step. Now we know data and we know data set. Data set is set of data, large number of data samples. We call it data set. Now we'll try to define another thing which is called dataset transformation. This is the main component which we would be using. So you can usually data, when you get data, so it may not be in the format in which you can use it. And then you may have to edit that data. If in very simple words, we can say we will edit something in that data. So that operation of changing that data of data set is called transformation, data transformation. So one example can be that your data may have some duplicate rows. So you would want to remove duplicate rows, or you may want to add some new column to that data, or you may want to select some specific rows where the column value equals some selected value. So like you may want to filter the rows, or you may want to add new columns. So these kind of operations are called data transformations. To do data transformations, we use something called transform. So transform is a generic term here. So for us, for our data prep kit, transform is something which can convert one table to another table. It will take one table, do some operation which will have some meaning, and then convert it into other table. So this is transform now we know about three terms like data set and data transforms. Now I will introduce you to a toolkit for data prep. Data prep here means data preparation. When we want to uh, uh, get or collect data, and we want to train a model or fine tune a model, between that we will have to do multiple sequential steps, which each of which can involve data transformations. So to make that easy, we have made one data preparation toolkit. It allows us to create new transforms. It also has a repository of pre-built transforms. So we have a list of transforms which are pre-built and which are part of data prep toolkit. So they can be directly used to implement our use case. And this data prep toolkit can process small data, it can process medium data, it can process large data, or it can process very large data. So this toolkit is something which will which is designed to scale from say 100 files of data to million files of data, and the code remains same. You only have to include more compute. You may have to run on multiple number of computers using cluster, but the transforms remain same. And this toolkit also allows you to read your data from local storage or cloud storage. And this toolkit can run in a Jupyter notebook, like in a simple web browser. It can run in a terminal. It can run in containers, Kubernetes. Like these are terms which are used in industry to run on scale. Scale means very large amount of data, very large amount of compute. So this also provides something called SDK. SDK means software development kit to write new transforms. So we will see the steps in which we will actually see how data prep toolkit looks like, how we can get it, how we can actually work on it. So we will also walk through a data processing pipeline. Data processing pipeline means that you have a sequence of transforms, one after another. Your data will go from one transform to other transform. So like first of all, if you want to process data, you need to get data. So first thing in the pipeline should be a component which gets data from somewhere. Second component may be something which removes duplicates. Third component may be that can select some rows. So we have a Jupyter notebook, which I will walk through, where we will have these steps of data processing. So we can connect the transforms together. When transforms are connected in a sequence, they represent a pipeline. So I would like to do some practical, and I expect that some of you may have computers with you, Linux machines or Windows machines, or at least even Python or a web browser or Jupyter notebook.
Shivdik, before now we get into hands-on, right, where people actually have to start coding, run their terminal or something. Maybe take a breather for some questions till now, right? If there are any questions from the audience around the setup, I think we can take them quickly now and then go to the hands-on.
Audience, you can ask your questions, any setup regarding the
Yeah, I
can we
see.
use Google Colab, sir?
Yes, Google Colab is available. Yeah. It's like Google Colab is one of the options, but if you don't have setup, if you don't, you face some problem in the setup, then only you go for the Colab option. Otherwise, I would like you to try it on terminal or Windows command line. Colab is there. Yeah, you can try it on Colab also.
Any other questions? Okay, maybe we can get started, and as and when questions come, we'll
Yeah,
answer.
yes. Okay. So, first of
There's
all,
one more question. There's one
yeah,
more
sure.
question. Can you explain more about transforms?
Yes, I would be explaining more about transforms in the coming minutes.
Yeah,
So
but
you just have to
yeah.
wait. And so transforms, as of now, you should know that transform means which can transform data. So it can be a simple function which takes in data, does something, outputs data. So I will show you some transforms. I will execute them, and I will also make you execute them if you have the setup.
Okay.
One more question has come. In case of image data, in which format we must train the model?
Yeah, so this thing is for every model, data is in a different format. So when we think of a model will take in something called embeddings. So in case of image data, the models are different types of models. So they can take images directly. So because they have their embeddings, they have the system in which they can consume images. So here we for text data, for multiple samples, we put the text data in rows and columns, and we store them as parquet. So this is mostly for network and storage efficiency, because that format is good for transport over network. It is good for storage, taking less memory. So today, the one which I will walk you through would be a text-based model, which has modalities of code and NLP. Like it can consume natural language data, or it can consume code like software written in Python, in C++, Swift, etc.
One more question. Give a real-time example for dataset transformation.
That is what the
That
session
is what the session is about, is real time
Mhm.
and practical industry. So that's what I'm going to. Now, it's good that people are actually waiting for the stuff which is coming. So I'll just let's have a look on GitHub. Okay. So one thing which I just showed you here. So this was the data sample which I showed you. So it had code, some code was written, some repo name, some path. So suppose I want to train a very big model, and the one big model which we trained, it needed code. So we needed a lot of code to train it. Where do we get that code from? So there are multiple sources. So if you just go to internet, you will find that there are sites like GitHub, GitLab, where we can host software code, where we can write our code. So this is like some code on GitHub. So GitHub is one site where people actually they can write code, and it supports something called versioning. So if you change something in the code, it will remember. So you can code for 20 days and you can go back to the code which you wrote on the first day. So that option is there using Git and GitHub. So that is called versioning. So if you just take a look at this, these are just folders. So code is in file. When we write code, we write files. We keep files in folders. So this is folder. These are multiple folders, and these are some files which have code. And when we put this folder on some hosted site like GitHub, we call it a repository. Now, thing is, on GitHub, we will have millions of repositories. So GitHub is one source from where we can take millions of repositories as data. So there are some data sets which are already made, like Hugging Face Code Parrot is one. They have already passed data from GitHub and created that data set sample. So this is what I showed you. This is one GitHub repository. So GitHub needs something called GitHub account. So I would like it is expect if there are students, they should have account on GitHub and other sites where you can code. So since our data prep kit is on GitHub, so GitHub is the best way to explore this toolkit. So this is
and Hugging Face is back if you want to show.
okay.
It's,
Yeah, this was some server was down, I think, when I was trying to show code parrot on Hugging Face. So now I will show you how data set looks like. So here, this was the one which I wanted to show you. This is a sample, and this is a this code parrot is a whole data set. Like it has very large number of such samples, and this is something which is very important. It is called a schema of data. So when you represent data, you should know what this column means and what this column is. So there is one column called code which has content of source file and which is a string type. Size is int type. So this is something called schema. So and this data set contains 30 programming languages, and it has multiple files. What I'm showing you is called data card of code parrot, and these are some licenses, these are some statistics. Here we would be using this data set, and we will do data transformations on this data set using data prep kit. Now I'll just briefly tell you about what is data prep kit. So if you see on GitHub, you can even search on Google. If you just Google data prep kit or data prep toolkit and IBM together, you will come to this link. It is data prep kit. So here there's a fork button. Here is a star. Here there are folders. So the way we work on it, suppose someone wants to contribute to it is, we these are like GitHub concepts. There's a fork. We click on the fork, then this repository is stored in my account. So I already have a fork. I can show you if you. So I I have a fork. When I fork, now this folder is available in my account. The changes I do would be in my account, and I can also submit the changes back to that repository. Then star is for bookmarking. We would like you to bookmark this repository for future usage. And then there is something, this green button. Here you see this link. This link is for this link corresponds to this repository, and we can download this repository from this link using git command. So you may be familiar with this. Some of you may be familiar with this git command. So it is in one of the prerequisites. So this folder on GitHub can be downloaded to my computer using git command. I'll just show you how to do that. So
one thing I would like to add here, ideally do it for your own fork, so that whatever changes you are making doesn't mess up the master branch.
So here I will show you. We have to write git clone, then the address which I copied from the repository. So this one command will download that repository to my computer. Suppose I want to name it repo for demo. I'll name it. So see, with these steps, we will download this data prep toolkit. So now I'll let it download. So now I'll tell you here, this is a toolkit, as well as it has a host. It also hosts some transforms. So if I go to this transforms folder of this repository, I will find 3 more folders: code, language, and universal. Universal, if I go to universal folder, I find some folders like resize, noop, dedupe, docid, tokenization. So each of these folder represents a transform. And suppose I want, there is one called no op. It is just for example. It does nothing. And like it's no op means no operation. So it does nothing, but it will write the same table as output. But it shows example how it is made. And there are readmes. There is a readme where we have shown how it can be used. And this is one way, but I will show you the easiest and the simplest way to get things up on your machine. So now we are still in process of cloning. And here, if I show you, we have some example notebooks. So this is what we would be using. Examples notebooks folder has code developers, language. There are multiple examples. So we'll go to code notebooks, code, and sample notebook. This is the one notebook which we would be using, which actually shows us it shows us a demo on building data preparation pipeline for model fine tuning. So it has steps. We will learn about these steps, what each step does, and how data gets processed. And before that, just for people, students who may not have set up, I will just try to tell you about setup again. So if you have Python, we need Python 3.10 or 3.11. If you and there is one easy way to install Python called Miniconda. So mostly we had shared some prerequisites with to install Miniconda and activate Python. And if you have not done that or tried it, you can try it. If you are using Linux, then steps are straightforward. But if you have Windows, then Windows has one option to run Linux. So you can for all Windows users, you can go to your search box in the command in the search. You can write CMD and choose this run as administrator. Then command prompt will open, and there you can write this command WSL -- install Ubuntu 24.04. This will install Ubuntu Linux on your Windows machine, and whenever you want to access it, you just have to type WSL, and you will get a a Linux screen where you can follow the steps. Once these steps are there, then we can actually like you can follow what I'm trying to do. You can execute the same steps. So thing is here I need some like component some applications like Git to clone. So I cloned it using Git. So otherwise we can also download it from here using zip. There is other option. We can download the zip file from here, download zip and unzip it. So this demo will run on Linux. So if you have Miniconda or Miniconda steps with you, then it would be easy. Just let me show you. Yeah. So we shared some steps to install Miniconda. So there are Miniconda can be installed from their site. Then we need to create one virtual environment with Python 3.11. Those who already have reached this step, they can skip this. Otherwise, Conda create data prep kit Python 3.11 is one step which we have to do so that we have working Python environment with Python 3.11, and then we can activate the environment with this step like conda activate data prep kit. Then it would be activated. Then we have to install Jupyter Lab. We have to do pip install of Jupyter Lab. So here I have seen that we have completed that download. Where is that? Okay. So we have some repos here. So I'll show you. Now we'll move to next step. So up to here, I assume that setups, people would be ready with setups and people would be comfortable with the setup. Anju, do you want a question?
No, I think, okay. So we won't be able to spend too much time on the setup, but if there is a quick question, we can take a minute and see if we can help, but then we'll move on to the actual demo. Okay, so seems like people are comfortable with the setup.
Okay.
Yeah, and if there are any questions, please feel free to post in chat. I'll be trying to reply.
Okay.
Yeah, one question has come from Rupesh Tahur Engineering College. Shall I read the question, ma'am?
Yes. Yeah, sure.
Currently, I am working on developing a DL model for image colorization. The data set I have consists of image pairs, colored and corresponding grayscale in PNG format. So if I choose model that are suitable for such image translation tasks, example CGAN, Pix to Pix, and for training this model, whether I can train it directly applying some pre-processing techniques like normalization, cropping, scaling, etc., and feed into the model in same PNG format, or should I pre-process and convert it to a different format? Example, NPY.
Yeah, I think it is better to do pre-processing, and you can also explore the steps. Like there are some open models available on GitHub also. Like OpenVino Toolkit has some, so they have uh, models to do pre-processing. So you can have some models. You can define data processing steps, and if compute is a limit, then you can go for normal image processing algorithms. Otherwise, you can go for DL based models, which are available freely to do resize, resample, like super that scaling of resolution, those kind of things. So it depends on you. And thing is, some experiments can improve the quality of your model if you improve your data. So someone may not be following that steps, but if you follow those steps and get better data, then your model may be better. And for your model, the model which you like, you have to decide on the format, what input it takes. So other like PNG, JPG, they are like for storage and how much resolution you can, like whether you want lossless or lossy, those kind of considerations. So I'll take less questions for image. I'll take more questions for uh, natural language or code based. Since my pre-processing pipeline, which I will show you, it involves steps like deduplication. So those steps are not there in the image one.
There's one more question, which is, can they use VS Code instead of Jupyter Notebook?
Yes, VS Code can run Jupyter Notebooks. So Jupyter Notebook will run in VS Code. You can you, but it's easy to whatever you find convenient. So some people find Jupyter Lab more convenient. Collab is also there. On the same Jupyter Notebook, there is a Collab link. If someone wants to run it on Collab, they can click on Collab link. It will open in Collab. Those who are comfortable with VS Code, they can open it in VS Code. So we know that the location is in. We have to clone the repository, or we have to get the repository to our computer. We have to get ready with Python virtual environment, which now we are ready. We have to install Jupyter if I'm using Jupyter Lab. So I have already installed Jupyter Lab with pip install Jupyter Lab. So now I have Jupyter Lab ready, and I want to go to the notebook. Examples, notebooks, and code. So here is my notebook. Okay. So I will take a shot at it because I have the environment ready. I have the notebook. Let us get it up. Okay, we have got it. Now we are ready for the pipeline. So you guys can also get the notebook ready and reach up to the notebook. Then we will have a walkthrough. So there is a setup. There are some setup steps. So first is this demo notebook will show data prep kit transforms. So thing is, we have two things in data prep kit. One is SDK, which tells us how to build transforms. Other is the actual transforms, which I showed you in the transforms folder, which are also uploaded to PyPy. So we can just do pip install and use those in Python. So in this Jupyter notebook, we will do pip install of those transforms. So first thing we will do, this is setup. We'll just come here. We'll execute this cell, which will install the prerequisites for us. Okay, we have to wait. We have to see the star. We'll wait. And thing is, we are processing data. So there are some interesting things which come when we are processing data. Processing data here, I'll first go to data preparation steps, then I will also discuss some challenges. So data preparation steps means we are just trying to prepare data. So if I think of this, that I want to use this data, I have some data, then I want to feed it to model. Between that, I will have to think of what can I do to make my data better. What are the artifacts I can remove from data? What can I keep? So it is better to keep less good quality data than to have large data which has lot of repetitions and others. So quality matters, and these preparation steps would help us in improving the quality. Okay, so here first step is getting the data. Just for this demo and for demos, to make things easy, what we have done is we are taking data from internet. We have other notebooks where you can actually get data from notebook also, from GitHub also. But here we'll get a data set with from Hugging Face, which I just showed. So data prep kit has options in which with which you can get data. So this is one Hugging Face data set. This is one cell which I am showing you. This will download 20 into 20. It means 20 files, and each row will have 20 rows. So just for this demo, I will process less data. Otherwise, we can process large data. If I have more resources, I can process the whole code parrot with this pipeline. But for this, we'll go for only 20 files. Okay, will 20 files means we'll 20 to 2400. We'll work on 400 samples. We'll download those samples. We'll create those files, and I'll tell you something. I'll show you something interesting here also. So in our notebook, in our data prep kit transforms, we have all types of many types of transforms. One is code to parquet, which is specially used to convert GitHub repositories to parquet files. So this one is in other notebooks. So this one is one option. Other is code parrot one, which I am going to show you. But this is for knowledge that data prep kit can consume, this can convert the zip files from here. Like from here, we can get a zip file, this zip file. If I have millions of these zip files, they can be converted into Parquet dataset with some schema. Schema means rows which had names, which I just showed here also with like this, like this. In such a format, it can convert the repositories into this format. So this is one, and here we have other one. Where it open, yeah, and here we will be using the Hugging Face one. So I'll just tell you that here we have some 8 steps, and each step is taking some input and giving some output. So output of first input of first Hugging Face to Parquet is Hugging Face cloud. So this input is this dataset name. So this will use this datasets library to download data from this. So this data is hosted by Hugging Face. Hugging Face is like GitHub of models or deep learning. So they host, like GitHub hosts code, Hugging Face will host models and datasets. So we can run this cell and we will get this data set samples from this in the form of Parquet files. So I will execute it and wait. So it has started writing. See, it is writing some files. Wait, let's run it. I think so many people on Hugging Face will bring down the Hugging Face server. So this is like we have got lot of files. Okay, when we click on this, it will download the data set from Hugging Face. So now we have this parquet. Now our job will start from here. Now we'll start understanding what is the data pipeline, because this was the component which is just getting us data. Now we'll be doing things with data. So here we learn that there is something called parquet, and this parquet has data. So we have this column is just we have added one column just to read this parquet file and show you how it looks like. So this 8 number column, if I execute it, then I get this. It will read the parquet file and show me that it has repo name, language, license, size. These are the column names, and this is some row. I'm showing only one row. Okay, this is some content. So this is how one sample looks like, and we have 400 of these. Okay, so now the steps, I will take a look at the name of the steps. So first step we will do is exact deduplication. What does it mean? Like from its name, it appears that we want to find some duplicates. So this is one component, one transform, one which comes as part of data prep kit, which can remove duplicate code, duplicate files. So if we take a look at this data set, we have rows and columns. Rows are like one file is one row. This is the format. So this file was from this repo, decred set dcrd. This language was Go, and content was this, and file name was this. Okay, so one file in one row. Suppose I parse data from CodeParrot or some GitHub or somewhere. It is a chance that I will have lot of duplicates. Like if you just fork my repo, you will have the file with same name. There might be many files for which the content is exactly same. So we don't want to give redundant data to the model. So what we want to do is we will keep only one entry. Suppose I have 10 entries which are same in the data. I'll keep one, I'll remove 9. So doing that, to do that, we have to do something called deduplication, and we call it exact because we will exactly match that this content should, since content column is the main column which makes more sense to me, I want to deduplicate only this column. Okay, so here in this transform, this is the simplest usage in the form of Jupyter Notebook, but this can also run as a command line application. So I can run this as a Python command, like Python something. I can run it in Jupyter Notebook. So I'll show you the easiest way of Jupyter Notebook with very less configuration. Okay, so here I see something called local config. Okay, here I see input folder, output folder. Okay, so thing is, I ran this first cell for Hugging Face, then it downloaded data into this folder, sample data hf2 parquet. I can even see it here. See it like, sorry, hf data hf parquet. See here I have the parquets. Now thing is, I will do to do exact deduplication. I need some source and some target output. So I will take this input folder, which is the output of the first stage. So Huggingface ingestion will write the parquet into input folder, into one folder. I will call it input folder now, and now here I will call a new folder as output folder. Sample data eddup out is the output folder. So now this deduplication should read from this right into this. So here I just set the inputs. This is a dictionary for me, and since I want to provide a command line, so I just convert it into string here. This one function will convert this dictionary into a string, which looks like a JSON, which is needed by this parameter. So these are 4 parameters which are helpful for doing deduplication. Deduplication means removing duplicates. How do you remove duplicates? You use some hashes. Hashes means you compute some function on this content, you get a hash, then for same content you will get the same number. So if the hash for two files is same, we know that this is a duplicate content. So we will use that concept in this transform. So there is one more interesting thing which I want to tell you now. It is that when data increases, when there is large large number of data, like very large data, compute increases. Like you might be able to process 100 files in say 5 minutes, but when they grow to 1,000 or 10,000 files, you cannot afford 1 day or 2 day to do that. What you will do, you will do something called scaling. Like you want to run that execution exact duplication in parallel on multiple CPUs, on multiple machines. So this exact deduplication and these transforms support that. Now I'll introduce you to some parameters which I didn't tell you earlier, which are in this setup cell. So we have these parameters called worker options and common configuration parameters. So here I give runtime number workers 2. So it means that I will use two parallel processes to process this data. So here it means that if I have 400 files, I will process 200 and 200. So I can increase it based on number of CPUs which are available to me. So suppose I am running on one machine, I have 8 CPUs, I can give it 6 also. If I have a cluster, say I want to run exact dedupe on practical use case, which would be 1 terabyte of data, then this number of workers would be say 300, 400. This will increase. The same exact dedupe code will run in multiple processes. Each process will be processing a fixed number of files, and they would do that over and over. And in the end, we'll get data which is deduplicated. Now, exact deduplication kind of transforms, they are kind of unique, because when you want to find duplicates, you want to find duplicates over the whole data set. Means if you have 100 files, you have to find the duplicate in the first and 100th files also. So you have to see all files at once in the memory. If it is 1 TB data, 1 TB data should be there in the memory while doing processing. That is why this component needs parallelization. This needs lot of this needs scaling. So that's why we have that 2, or it can be increased. So this component supports that. So what we did is we just we have some parameters, like we have given here 2. So this is for number of hashes, and here hashes name is for our store, where we store the hash for this content. So it will also do parallelization, and when I run this, I see that it is the complete one, that one, two completed 18 files. So it is completing 20 files with 20 samples each, and then I get some output. Now let us take a look at the output. So when I run this transform, it will give me two type of output. I can show you the output. Dedupe out. So here these are all 20 files which were transformed, and this is one something called metadata.json. So in we just don't run our transforms. We have to take in account of other things also. Like these are very sensitive jobs. If I am running deduplication for say sometime 10 minutes and something crashes and I have to run it again, then I should have some information. What was successful, what was there, what was not there. So we create one metadata.json. So whenever you process with one transform, you will get a metadata.json, you will get data. If we go through metadata.json, it has some interesting information. It will tell me how many files are there, what was the size of input, and what was the size after duplication. See, it removed something, size has decreased. What was the time it took, and how many CPUs were used, were available, and then what are the paths. So these files actually help us see and verify that the job was successful or not. And there is one more thing supported by this. It is called checkpointing. So checkpointing means so there are some transforms which support checkpointing. Checkpointing means that it remembers that you ran it last time. And suppose you were processing 200 files, you ran it for some minutes and it crashed, and only 5 files were processed. Next time you will run, it will not process those 5 files. It will start from the it will process the next 15 which are left. So that is called checkpointing. So that feature is available in these transforms. So we can choose we can enable checkpointing. Then it will or it will resume the transform rather than redoing it again. So first this deduplication transform doesn't support because it scans the whole data at once. Other data transforms which I will show you will support checkpointing also. So now first component we saw was deduplication, and that is a interesting concept that we can deduplicate. Now there is one which Shelja explained a day before. It was about fuzzy deduplication. This is something which is like you don't find exact matches. Here you will try to find approximate matches. Now suppose we want to remove we don't want to keep data which is similar. Sometimes some people may have data which is same, but the function name is different, or someone has added a new comment and that data is 80% similar or some percent similar. So we have another stage called fuzzy deduplication. So we can run this cell. It will take the exact deduplication output as input, and it will like uh, this will take some focus from your side because this is interesting transform. Others are easy. So here to do deduplication, we will use some algorithm called min hash algorithm. And exact deduplication, we were able to do it because we were able to calculate exact hash on the column. So here we will need some extra information which is not yet there. So for running fuzzy, we need some extra information called hash column and hash IDs. So we have one component called document ID generation. So this is running as part of fuzzy deduplication. So we will run fuzzy redup in two steps. So this fuzzy redup will have two steps. One is doc ID generation. If I execute this step, it runs a step called document ID generation. So here we will add new columns. So one is hash, one is ID. So we just added new columns to this data because we will want to use these columns with main hash algorithm to find near deduplicates. So this cell, if you go to this fuzzy deduplication cell, you can execute this, then it can move to, so this cell will show us the parquet. So we are seeing this one go sample. So here we can take a look at the metadata JSON also. In metadata JSON, we saw, okay, 20 files were there. Then we resulted in 20 documents output. So because we just added a new document ID, we didn't do anything else. So number of documents in start and end are same. Number of size would be okay. Then this is the step which we will use to do fuzzy duplication. So this cell number, this cell you can see after FD. So this cell fuzzy deduplication needs two columns. One is the column which you want to use for fuzzy deduplication. It's called doc column because I want to do deduplication on contents column. And other is a threshold which will define that this similarity threshold for finding the similarity. So I can choose these values and run this. So currently it would be using default threshold, and otherwise I can update it here. So this is the place where we update the columns. Like I want to run it on contents, I put it here. These are my hash column and int id column names, so they would be using this. So here I can fill parameters and I can run this cell. I can go to this transforms. If I want to have more information about this transform, suppose I'm very curious, I can go to this transforms, universal and fuzzy, fdedup. Here I can find documentation, how it runs, or in the source folder, I can find in some information how to run it. This one local. So here I can find, okay, how to update the parameters. What is the value of the parameter which I want? So this is one file, transform. This is the location where I can find the file which has the extra parameters which I can use here in the notebook. So currently I'm going with the default parameters. If I want to change, then I can take a look at that sample. I can add those parameters. I can tweak what I want. So when I run this, let's see, it runs, it has completed processing. Then I see the metadata. So here I have that, okay, it used one actor for doing the processing. Threshold was 0.8 here, default threshold. Then uh, these are internals. It uses buckets and min hashes. So these are the numbers. It used this size as input, and the resulting size was this much. Oh my god, we have lost some data. Yes, so this guy has removed some near duplicates. So now we have less data. Here we had this 120 KB data. Now we have 58 KB. So this step has reduced our data. So in data processing, we want to clean our data. We want to remove redundant. So we have run two steps where we have lost some data and we have got good quality because we have removed some duplicates, exact as well as near duplicates. Now what we will do is we saw that in our data set here sample we have some columns like language column. This has some value called language name. Go is a name of a language, Golang. Then there can be C, C++, multiple would be there. Can okay. So now we'll go to next transform where we will actually choose some languages. Like here we are trying to see some samples. These 10 samples, we'll take a look at 10 samples. Now we have repo name, languages are Go is there, C is there, JavaScript is there, Go is there. So these languages are present in my data set. Okay. So what there may be multiple more than that. What I will do is I have a transform called programming language selection. So this is a transform. So here these are the steps using which I use this transform. So in these steps, we are using this transform called proglang select transform. It takes three parameters. One parameter is allowed languages file. So we will have a file where we will put a list that I want only these languages. Suppose I want only Golang, C, JavaScript, and I don't want to have Bash or PHP or TypeScript or other Markdown, these kind of languages. I want to filter them. This transform is for doing that. So this is actually an annotator. So we'll learn this concept now. So some transforms are such that we want to maintain some information which may need later. So this is one transform which will mark, not remove. Earlier transforms we saw two transforms, deduplication transforms. They actually reduced my data. They found the duplicates, removed that data. Now we have come to fourth transform, which will not remove data. It will just mark data that this document was this document was marked by programming language selection. Then we will mark our data using multiple such transforms. Then we will use another transform called filter to actually apply SQL like conditions to filter. So from here, you just keep in your mind that we will do annotation here. So it is a selector. We'll do select. Select means we'll just mark. So we just created a file. We have a file also which is online, which is as part of which is a sample test file as part of this repo. So I've just commented that we'll build a file here. We just want JavaScript, C, C, Go, and Java. Only these languages I want to filter, to mark. Okay. Then I created a file with this name. I set the input and output folder. Then this transform needs the name of the column where language would be there. So for me, the name of the column is language. I'll check here. See, where is that? Yeah, this is the name of the column is language. So I want to use this column. So I will choose this name as language, and this is the output column name which I want. I will just name it language of interest. This is called annotated column name. I passed it to this lang output column key, and I'll run it. When I run it, we see that it takes, see, it took very less time because there were very less samples. So I can take a look at metadata JSON. Now input and output size should remain same. Like it might fluctuate little, but rows will remain same. Document count will remain same, and what will be added is this column. These two columns were added by doc ID. This was added now. See, value is false, false, false. So we don't want this. And some would be true. So this is used for selection. So when we use this, let me try it once. Wait, we can use this also. This run it. So this is we have seen that this transform will mark something. So now we'll come to next step, which is called code quality. Okay, so code quality is one. This VPN is giving some problem. So wait. Let's see if it connects. Oh wait, this. Okay, we'll see this code quality. So now thing is, and in case this, I'll also have one collab session open so that we can also show how these things can run on collab. So we can click on the collab button and it will open in collab. Same things which I executed here can also run in collab. In meantime, we'll run one session here. We'll come back to it. Run all. Okay. So we were here on this transform called code quality. So now up to here, we have seen some transforms which are like adding some columns or which are filtering some, which removing some rows. So now there is one transform called code quality. This is one transform which we use to filter bad quality code. So we have some metrics based on which we define that this code is not good. We don't want to have this code. So in code, there is something very interesting. If you take a look at code written on GitHub or others, you will find that some code may have Jupyter notebooks embedded. Some code may have images in it. Some code may have very large arrays. Some code may have very large binary content embedded in the source. So those kind of files are not needed for us because they are kind of noise. So we can specify some conditions to mark those kind of files. Like I can choose that I want only files where number of rows should be between 10 to sorry number of lines per file are from 10 to 500, like this. If I see code where everything is in single line, I don't want that. If there is only one line in the file, I don't want that. So those kind of things can be filtered out or marked using this code quality filter. So we can run this code quality filter and it has some code quality metrics. Based on that, we can mark the code that this code has HTML, this has XML, this has this. So later we can use that marked things to filter that code. So I'll go to main steps again. So these were the steps which we were showing in the pipeline. We understood ingestion. This is duplication. we understood that we can mark programming a language selection. We understood that we have annotators using with this code quality annotator, using which we can add something which related to code. Then we can add something called filtering. Then we can do some semantic ordering, and we can do tokenization. Now we'll try to understand.
Shivdeep, I think it's a good point to take a 2-minute question session at this point, right? We are going into a next level of filtering and semantic ordering. So you have shown us some very good transforms, how they're transforming data, what is it that we should expect, what does the metadata look like, so you can pick back where, let's say, if a program crashes and you can do it again. So audience, if there are any questions, I hope you are able to follow. Of course, it's a lot, I'll agree, and that's why you have the code at your hands. The repo is in open source, so feel free to go through it and take a look. Everything is documented. But if there are any quick questions now, we'll be happy to take that. Yeah, I think there's a question. It will be better if a use case is given for each transform. So I believe you were.
I'll go through the use case. Yes, good. This is a good question that we come to use case. So right now you will see on my screen Granite code models. You can Google Granite code model paper like this. You will get one paper, a research paper. So just the one model which I showed you here while doing coding, this one. So this is one model. Okay. So this model was trained using some data. And this is a paper which tells us about how was that do. So this is the practical use case. This LLM, building this LLM is the practical use case. This is the paper which gives the steps. And if I go to this, data will go to this data part. So here, while building this, like this was prepared by our teams at IBM Research. So here, if you see, we have detailed these steps. So these steps are the same which were practically used to prepare pre-training data for this LLM. So we had data, just like I showed you from, we pulled it from CodeParrot. We had some of the sources, they are detailed here. So data crawling and filtering steps. And this is the, see, we have those steps, exact and fuzzy deduplication. We did those steps, so if you go through this, you see that while preparing this, creating this model, it is like we have to do these steps on data. They were done. This exact and fuzzy deduplication, which is exactly the same, this has been open sourced uh, as part of data prep kit. So this duplication was used here. So now we have open sourced it as part of data prep kit. So this is one transform, like to do duplication. Then the next one, this malware filtering, PII, these were done. So this paper is one which you can take a look. You will, and the thing is, earlier when ChatGPT etc. came out, they were more an enigma because people didn't know how these big tech, how they are, what are the steps they are doing to train these models, what are the steps they are doing. So IBM has open sourced this effort. So you can check out this paper, Granite code models, and there is one more. It is also Granite context, large context model. It These two models these two papers, they detail the steps which are practically which were used by this. Okay, this is one another paper. Here also, we for long context modeling we used there was one approach used which was repo level ordering. I'll come to that later. So there is one transform which is doing some stuff which is in this paper, and this
And these
granite.
models are also released on Huggingface.
Yes, this model is available on Huggingface and can be used via Olama. So you can run this model on your laptop. You can run the small version of this model on your laptop also. Like there's a command, you can go to Olama, run Granite. You can it will download. It's some 8 GB, 12 GB model. So any other question? So this is a practical use case, and this is the pipeline. The pipeline which I'm showing you, it is though it is manual, like I'm running it in front of you, but these steps are very similar to the one which are actually used while processing data. So when I want, suppose I want to process some data, here I mean that suppose I want to train him, I'm a college, or I have lot of documents. I want to query them. So what I can do is I can collect all the documents. I can prepare data from those documents. Like we have the transform which can convert PDF to Parquet. So all those PDFs can be converted into Parquet, and we can clean, deduplicate, and then fine tune some model like Granite or some other models, open source models. And then we can use RAG. RAG is something called retrieval augmented generation. It's like we can actually talk to our PDFs. Suppose I have 10 a lot of data PDFs. I can create data from that. I can talk to those PDFs, and I can clean that data using this pipeline. So that for that also, you can go to data prep kit examples. There are examples which are coming up for that practical use case also. So that is one chatbot use case. Like if you want to do chatting with your model by fine tuning, so there you can use your own data and clean. So this is the data preparation kit which actually does the steps which are needed before training LLM, because data quality and data is something which controls how well your model performs, how much it will hallucinate. So these any other question, like these are practically, like this is not some theoretical or some imaginary use case.
Yeah, and
This is
these
the
are also
actual
used
use
for
case.
fine tuning the models.
Yeah, this
Right,
is
so
same thing. Like fine tuning, pre-training only differ in the amount of data for us. Like your fine tuning data can be in GBs, like 5 GB, 6 GB. Pre-training data would be 5 TB, 6 TB, or maybe 50 TB. Maybe it's like in TBs or petabytes, maybe. Like data, there's a lot of data available. So these are each of this is a transform, like this is a transform stage. So this is how I'm running this transform. This is for Jupyter Notebook. For more details, we can go to the code. We can go to documentation also. Like if I go to data prep kit, we have documentation also. Some documentation is there. So here some tutorials are there, some transforms are there. So there is lot of documentation in the code also. So if you go to doc folder, you will find some samples where we show how to create, how to run this use case. Anjal, do we have any other question also?
Yeah. I'm trying to answer some. There was a question around the rules with data quality, code quality annotations follow. I've shared the link for that. There's a comment that fine tuning is giving an error. I think somebody is trying to run fine tuning towards the end of the demo.
Which
So it's Monisha. Can you share?
no, okay, I got it.
Yeah.
So I think thing is, if you have if in the there is one column, like there is something called filter. There's a filter, filtering transform. I'll show you on my screen. Will not filter something, will actually take less data. So you just comment this language of interest one. So it will include all languages now. You will have some more data. Otherwise, we need some more data. We are processing only 400. So we may not have good data to do this. So you just comment this language of interest here in filter and run from the filter downwards. Execute all transforms again.
Monisha, I hope that answers your question. Try that.
So this is just for example that we can add conditions. So I can add condition, I can comment condition. So I'm coming back to this. I think someone is moving faster than me.
Yeah, it's okay. I think other question is pre-training can be done in cloud only, but
Yes. So thing is, yeah, that is a good question. See, training, pre-training, these things are similar, but pre-training involves a lot of data. So if you are actually creating a LLM, pre-training can be done in cloud. Like you will need a cloud for that, and that pre-training, it takes months. So these ChatGPT guys, they or IBM or we all, we take lot. It will take lot of days to run, and it runs on clusters. Like many VMs are used, GPUs are needed, but fine tuning is something which is a small version of that. Fine tuning can be done on your laptop. So that is the thing is the approach. What they do is they take a model, they take data, they will pre-train it with large data. So it is generalized to understand that data. Then we will fine tune that data on a specific use case. So suppose I want to I want to uh, make my model better only for Python. So I can have some curated Python samples from some books which are written in some particular way. Then I can fine tune with that, only that. So then my data can be in some MBs. If data is in MBs, we don't need cluster. And this data prep kit has transforms which can run on cluster as well as on this what we call laptop. So they scale. So you can do fine tuning using this Jupyter notebook here. But if you are in a company, you're working in a company, then you have access to a cloud. There you can use similar approach or this notebook to run it on cloud to process more data. So it is about like there is something called scaling which is inbuilt into it. Like it is parallelizing. So if I have some files, 100 files, we are parallelizing on 4 cores. So if I have TVs of data for pre-training, I will need more. So my 4 cores would be cores of cluster, so they can be 400 or 4000. And my data would be more.
Yeah.
So that is called scaling. So things remain are similar. Code should be designed. Some code is designed in a way that when data increases, you use parallel or concurrent processing to process chunks of it. So what you understand at this level is what would be applicable at that level also.
I think we're good to resume.
Yeah. So yes. Okay. I think we have less time left. We'll resume. We'll,
Shivdeep
we'll
ji, any idea on how long will we take more? Just for
Only two. I'll wrap it fast because only 2-3 things are left. I have explained these transforms. Now, maybe in 5-10 minutes, I'll take questions.
Right. And one thing, the third session is also on data
Yeah, yeah.
prep kit.
Yes,
where
we have another session which would be taken by our colleagues. It is on how to write these transforms. I'm
Okay.
showing how to use this. There would be a session hands-on where we'll make you write something like code quality. Like this code quality is there.
Okay.
So we'll make you write something and on locally, like it can be easily run locally and it can be easily used locally. So here we just I was discussing code quality. It will annotate something. Now we'll come back to a common filter called filtering. Filtering is a step where we just pause, just like we were discussing. Now we paused and we took some questions. So in the filtering step, our pipeline will pause and think, and we will use some conditions to remove and decide what is good, what is not good. So we have defined something called filter criteria. We will decide that, okay, I want this language of interest. Don't want other languages. I want number of lines greater than 10 and number of lines less than 90. This is a good condition to filter some code where people have written arrays which are very big, or someone, there was one use case, practical use case which I remember. There someone has embedded a Jupyter notebook in a HTML file. So it's not needed. It like junk. You can just remove it. So this filter criteria will decide what will be kept. So we have decided that these will be kept and these extra columns we will remove, and then we will run this filter. And when we run this, we'll see that actually it will reduce some data. It will reduce the data which was marked by chosen by code quality and programming language selection. Now we'll come to this. This is actually somewhat tedious. Semantic ordering of code files. So I just showed you. I will uh, just take a look at this name. This name looks very technical. Semantic ordering of code files. So this is a novel approach which IBM has used in this paper. There's a paper scaling granite code models to 128 context. So we try to uh, so every LLM has a context window size. So wanted we followed one approach where we tried to scale that to a bigger context window. There we trained our model with we actually followed an approach which is interesting. I'll tell you here in this paper it is told. So it's like your code is in when you download it from, it was from repos, but when we are processing it, we are seeing it at document level. And sometimes within a repo, code makes sense. So what we tried is we tried to group the code into repos, and then we try to find the relation. It's like, suppose you have a repo, some files are important, some are not important. Readme like is important, and some file are needed for other files. Like if I have 3 files in a repo, sometimes I would be importing the second file in the third one. So if we present the data to the model in a way that whenever it sees the next document, it has already seen the previous document. So to follow that approach, we did something called semantic ordering. We ordered the files in the repo in a way how they were used. So if I am doing like in C hash include something .h in some file, I would uh, put that .h file first, then I will put put the file where it is used after that. So that way, the data in the model is arranged in data presented to the model was arranged in such a way that it can make sense of what is presented to it, because if it is importing something, the definition was before that. So doing that experiment, we found that there was a lot of improvement and we were able to scale. So this is one paper which tells about that. So this one transform will do that. It will do the similar ordering and divide the it has some options like repo level output by languages, so it can give the output in specific folders. Like it will put all C code in C folder, put all Java code in Java folder, like this. Then up to here our data is almost ready. So now I'll go to the steps again. I showed these 8 steps. Okay, they were running one after other. This was ingestion, it is just review. Then this was removing duplicates, marking something, removing what is marked. This is reorganizing data along with repo in a way similar to this paper. And then we are ready to feed the model, to feed the data to the model, similar to what we do. Like suppose I'm having lunch, want to have food, I will have a plate, I'll have some salad chopped into some pieces so that I can consume it. Same way we have to feed the model in a way it can feed. So what we feed models is tokens. It is called token. So there is one approach called tokenization. When you have data is ready. Now you have to divide it into tokens, and those tokens would be given to model to fine tune or pre-train or do anything. So when you have reached up to tokenization, you have done the steps of data cleaning. Now tokenization depends on the type of the model which you are using. Suppose I'm using Granite, uh, then there would be one tokenizer for Granite. So someone using Llama, there would be tokenizer for Llama. So every model comes with a tokenizer. So this is one step. This is a tokenization transform where we can actually pass the tokenizer that I want this tokenizer. I want to use this tokenizer to tokenize. So currently I haven't passed anything, so it will use default llama. So we can go to this repository, and here I can show universal tokenization. So this is one component which will do, which can do tokenization. So if I go here, so tokenizer, this is the default tokenizer. So I can pass different name there in my notebook. I can pass chunk size, different chunk size. So these are model specific things. So and right now what we have learned, I'll just recap. We have learned about a data preparation pipeline. I call it pipeline. We can call data. We have learned about data preparation steps. Okay. Why are they called a pipeline? Because each step is a independent step, and each step is called a transform. So we can run it as like here we just ran it in a Jupyter notebook. In practical use cases, there's something called workflow which is used. So some people use different things for workflow. We use Kubeflow. Kubeflow is one. So in each transform, you will find KFP array folder. So this is something called automatic, or this is also a pipeline. So one pipeline I showed you, which was very basic, very manual, just to show you. This is how it would be used in the industry. KFP array. This one will be converted to a format which will have a UI. There you can connect the components, add those parameters, run. Then this will run on cloud, and it can do some processing. So this supports all kind of runs. So you can run it on Kubernetes on cloud when you have very big data. You can run it on local system. You can run it on local cluster also. Like suppose there are 5 students in the hostel. They just want to use their own 5 computers as a single cluster. So it is easy to set up. We support Ray. So you just have to enable a Ray cluster, like run 5 commands on 5 computers and run data prep kit on one. It can use all for all that cluster. So that is so it is easy to set up, easy to do, easy to learn. So I recommend you to take a look at that and bookmark it for your usage. Star for can try if you have like if you want to learn more like this is called, this is something called data engineering. Data engineering is a big discipline, and data prep kit is the current upcoming one of the upcoming toolkits, which is actually very fast. That it is faster than some of the some of things which are available in the market. Like when we compare them together with for large data, this is a good product, but it is easy to learn, it is to use. You can use it on laptop. That is how we have tried to design it, that you can run it in collab. You can just pick any transform and run it. So rather than just being a method to write transforms, it is also a repository of some transforms, so where you get pre-built transforms, because sometimes you just want to train a model. You don't want to write transforms, you just want to use. You want to do deduplication, you want to do profiling, you want to resize your data. So I think I can take questions now.
Yeah, I think it's a
My
good place to
session is
stop.
up. Yeah.
Yeah. Yeah, so moderators, over to you. I think we have presented and covered the stuff we wanted to for this session.
Robin, are you there?
Yes.
Yeah.
Okay.
So,
Yes,
yeah, the
ma'am. Go
session
ahead,
is
ma'am.
over.
I will
No,
share.
you go ahead, please. The session
Yeah.
is over. If there are any questions, students kindly refrain from using the chat box. Otherwise, we'll have to disable it again.
Okay. So it's an interesting session now. We are going to have a Slido quiz. So this is a testing to understand how much you have learned from this session. So now Kishore will be pasting the Slido quiz in the chat box. So you just log in. So when you are logging in, please give your name and a hyphen your college short name. So for easy identification.
Model.
All good.
Okay.
All good.
So I will share my screen now. Okay. So are you able to see my screen?
Yeah, we are able to see.
Yes. Okay. So I will start the quiz.
See, the
Kishore,
Slido quiz will not be responsive on your Zoom screen. You'll have to stay on your browser and click the answers on your browser. So the link that has been pasted by the PALS PMO office on the chat box, kindly click on that link. It will take you to the browser, and on the browser you will be asked to register, wherein you'll have to give your name and your email ID and register it, and then get ready to take the quiz only on your browser. Kindly don't click on the Zoom screen and write back to us saying that we are not able to select the answer. The Zoom screen will not be responsive.
we will wait for another 1 or 1 minute. Then we will start the quiz. We cross 500, then we will start the quiz. I hope Kishore will be posting in YouTube as well. Okay, so now I will start the quiz. Your first question. So in what format is the dataset stored by use by datasets? So you have a 20 seconds. Please answer in browser. Don't see in Zoom screen. Okay, so around 41%. Let's see. Okay, that is answer is correct. 41% of people have answered correctly. So we will move to the next question. Do all the modules in datasets have to be always run in the same order? There are two options, yes or no. So you have 20 seconds. Okay. So around 57% said yes. Let's see. Okay, 43. That is the no is the right answer. We'll move to the next question. What field in the parquet file stores the actual code content? We have four options: contents, programming language, title, and document ID. We have a 20 seconds, 8, 7 seconds. Please answer quickly. Okay, let's see the answer. Okay, contents A is the right answer. Around 34% have answered correctly. We'll move to the next one. Which field allows to uniquely identify a code file row in parquet? So we have four options: doc ID, contents, ext, and unique ID. Okay, 4, 3, 2, 1. Let's see the answer. Yes, around 51% have given unique ID. Let's see the answer. The answer is A. So 30% have answered correctly. Next question. Document ID serves the purpose of, you have four options: uniquely identifying a file, adding the ID to the code files before processing, has no purpose, good to know. Have 8 seconds. Okay, let's see the answer. Yes, the answer is right. Around 66% have answered correctly. Next question. Can I select which programming languages to process? There are two options, yes and no. Okay. Oh, 92%. Yes, that is right. We will go to the next one. What is the license of data prep toolkit? You have four options: GPL, BST, and Apache 2.0 and MIT. You have 7 seconds, 6, 5. Okay. Apache is the right, around 65% have answered. The final last question. Which models act as annotators? code quality, exact dedupe, fuzzy dedupe, none of the above. Okay. Around 40%. Yes, that is the right answer. Now we will see the leaderboard. I think you can see now the Zoom screen. So Puvita from TEC, I think Tahur Engineering College, Deepak Kumar and Jiva Kanapati, Karthikeyan and Madhavan. So they have answered all. The first one, Puvita, has answered 1.110 seconds. Okay, thank you, Puvita, Deepak Kumar, Jiva Kanapati, Karthikeyan and Madhavan. Thanks for your participation in this quiz. Now over to the speakers. I will stop my screen.
Robin, you'll have to unmute, co-host CNC's other device. There is another device that he wants to be
done, ma'am. Done.
Yeah. So we are open for questions now. If there are any questions, we can take. Otherwise, we are already 10 minutes, almost, 7 to 8 minutes delayed. So are there any more questions for the speakers?
I think CNCS. You can raise your hand and ask your questions also.
Okay, I think you can request CNC, Robin.
Yeah. CNC?
Yeah. Thank you.
Okay.
Thank you, Shivdeep and Anchal. I think it's a very deep subject. In about an hour and an hour, little over an hour, you actually walked us through so many details. I was just taken 40 years back, while whatever you talked about today is about, several decades ahead from now, So I remember way back in 70s, 80s, there was a team in New Zealand. They were frustrated with, changing specs from, when they had developed for a banking customer. They were actually frustrated with the specs, changing volatile specs. Whenever they took a version of the application to the customer would say, no, we want this change. We want that change. So the team was frustrated. But in 2 weeks, they came up with an application generator, it was called Logic Information and Network Compiler. So you put the logic, put the data that the customer wanted, what kind of network, like, in any bank, you'll have a teller terminal, you got actually ATM, and you'll have various end users. They actually came up with the whole banking environment, they abstracted and built a whole lot of tool called LINK. You may not be finding it in Google because it's very old, 45-year-old system. I was reminded of that, all of whatever you said, it took me back to, the late 80s, when actually I attended a 1-week workshop on how to use Link and develop applications. It was so generic. It is not comparable to what you have. Whatever you have is Granite or whatever you have is not comparable. But it was good. We could generate applications for different domain like manufacturing or stores or whatever it is. I think it is amazing the way this particular toolkit is excuse me, able to generate this code. C, Java was looking for COBOL in that list, but COBOL was not there. But I'm sure you wouldn't ever develop something to develop, write a COBOL program. But it's very interesting. I think a lot of things is covered, a lot of things are covered in this. And with the next session, building your own data preparation modules using data prep kit, I think the students will have a lot more experience hands-on. I mean, the way that actually some of the students are asking questions and some of the way people are actually doing something on their own with this toolkit in parallel to Shivdeep is very gratifying that people are actually come prepared. Thanks to all those, I heard only one name, Monisha, somebody who had some difficulty, and Shivdeep really acknowledging, very broad-minded, saying that some of the people are ahead of him. I think Shivdeep, in spite of your deep experience and whatever you bring to the table, there are a few who are going ahead fast. I think we must thank you. Actually, in absentia, probably you trained them on the toolkit, and it's very nice. So, without much ado, I think I would like to invite the students to the next session on Saturday. Please note the timing is not the same time, like 1:30 to 3:30 or whatever. It is 10:30 to 12:30. I think it's in the morning. So please join the session. And definitely, I feel that there'll be a lot more learning and hands-on. You will take back a lot more things, when you go back to the college and when you start working. Thank you very much. Thank you, Shivdeep and Anchal, for your time again. We appreciate. So maybe on Saturday we'll get to see different IR scientists.
Thanks.
Yes, yes.
Thank
Thank you.
Thank you.
Yeah.
Thank you, Mr. Juan and Anchana Goyal. A few instruction to the participants. So after this session, we will share the recording of the session and the feedback link. We will send it through your mail. So please submit your feedback. Feedback is important for us, and watch the recording as well. So as CNC has mentioned, so the session 3 will be on Saturday, 10 a.m. to 12:30 p.m. So it is in the morning session, not in the afternoon session. So please kindly note. And thank you. Thanks for joining this session. Thanks to all the participants who have attended throughout the session. So thank you very much. Thank you,
Nice.
Mr. Chata and Kishore from PMO. Thank you, Mr. CNC and PVM.
Okay.
And other champions who have joined the session.
Okay. Have a nice evening. All okay.
Yeah, I will stop the recording. Kishore, you can, ma'am, Sujata ma'am, if you want to add anything.